Hey everyone, you know all those complex web apps we use every single day? Ever stop and wonder what's actually running under the hood? Well, today, we're pulling back the curtain on the hidden architecture that powers a massive part of the modern internet. It's a fantastic question, isn't it? When you use an app, what you see is the slick front end, the buttons, the cool animations, but the real magic, the heavy lifting, that all happens in a place you never see, the back end. And that's exactly where our story kicks off. Okay, so to make this feel a bit more real, let's just imagine a service called Assignment on Click. It's a platform that has to be super fast, totally reliable for millions of users, and of course, secure with all that student data. You'd probably think it needs the absolute latest, most cutting-edge tech to run, right? Well, here's the twist. The powerhouse behind services like this, and we're talking countless real-world giants from big banks to huge e-commerce sites, is very often Java. Yeah, a language that's been around since 1995. So how on earth does this decades-old technology stay so dominant? It really comes down to solving three huge fundamental problems. First up, the problem of a messy, diverse digital world. Back in the 90s, if you wrote code for a Mac, there was no way it would run on Windows. It was a developer's worst nightmare. But Java was created with an absolutely brilliant solution to this. At the heart of Java's solution is the Java Virtual Machine, or JVM. The best way to think of it is as a universal translator. Developers write their code just once, and then the JVM steps in as this middleman, translating that code for whatever device it happens to be on. A Mac, a PC, a Linux server, even your smart fridge. And this leads to an incredible result. Write once, run anywhere. Now, that isn't just a catchy slogan. It was a revolutionary concept. It meant businesses could build one application and then deploy it globally on countless different systems without rewriting it over and over. We're talking efficiency and reach built right into the core of the language. Okay, let's move to the second major challenge and see how this all connects. Scalability. You see, it's one thing to build an app for 100 friends, but it's a completely different ballgame to prepare it for 100 million users all around the world. This is the question that keeps developers up at night. Seriously, it's the reason websites crash during a Super Bowl ad or a huge Black Friday sale. If your app suddenly goes viral, it can't just fall over. You need an architecture that can grow almost infinitely without breaking a sweat. And the old way of building things just couldn't handle that kind of pressure. The solution was a major shift in thinking. Originally, apps were built as monoliths, one giant interconnected block of code. The modern approach, which we call microservices, is to break that monolith apart. So you have one small independent service for user logins, another just for payments, another for search, and so on. So think about it. With a monolith, if you need to update one tiny feature, you have to redeploy the entire application. And if just your search function is getting overloaded with traffic, you have to scale up everything, which is incredibly wasteful. With microservices, you just update or scale the one small piece you need. It's agile, it's efficient, and it's truly built for growth. And this is where Java really shines again. See, it's not just a language, it's a whole ecosystem. You have these powerful tools like the Spring Framework, and specifically Spring Cloud, that give developers everything they need to build, deploy, and manage these complex microservice architectures really, really effectively. Now for our third and final challenge, and you could argue it's the most important one of all: security. An application that handles user data has to be a fortress, and Java was designed with this in mind from day one. It's not just a single feature, it's a philosophy of defense in depth. Java approaches security through three reinforcing layers, which makes it incredibly difficult for attackers to find a weak point. The first layer is the language itself. Security isn't an afterthought, it's baked right in. Java includes powerful cryptographic libraries and enforces really strict rules on how code can access system resources. This foundational layer prevents so many common attacks before they can even get started. The second layer is how Java actually guides developers to write safer code. Its structure, with features like static typing, which basically means the code is double-checked for certain types of errors before it even runs, catches common programming mistakes that could otherwise become security holes. It actively discourages the practices that lead to those infamous vulnerabilities, like SQL injection. And the third layer is that incredible ecosystem of specialized tools.
Frameworks like Spring Security and Apache Shiro provide ready-made, battle-tested solutions for complex tasks like user authentication and permissions. So developers don't have to reinvent the wheel. They can just use the same tools that are trusted by the biggest companies in the world.
So, we've seen how Java tackles portability, massive scale, and ironclad security. Which brings us right back to our original question about this seemingly old language. Let's just put it bluntly. We're well into the 2020s. With so many new, flashy languages popping up all the time, does Java still have a place at the top table?
Well, the answer is pretty clear and authoritative. It's not just one thing, it's the combination of that platform independence, those built-in security features, and that massive ecosystem of tools that keeps Java at the forefront of serious enterprise-level development.
So, when you boil it all down, Java endures because it provides a complete, time-tested solution to the three biggest challenges of modern web architecture. Its portability lets it run anywhere, its design is perfect for scalable microservices, and its layered approach to security creates a true digital fortress. And that leaves us with a fascinating thought for the future. Java has already evolved from monoliths to microservices. So as we move into an era of AI-driven applications and even more interconnected systems, what will the next great evolution of Java architecture look like? Well, that's the question developers are working on right now. Thanks for tuning in.